Hey Ross, how's it going? Welcome back to Interconnects. What did I take a many month break off podcasting? I've been too busy to do all this stuff myself.
Yeah, I was trying to think of all the things that happened the last time we did a podcast like a year ago. And I think in AI time, that's like 200 years. So I,
Yeah,
I
so I
think
was
we both
looking and
haven't
then
aged.
we talked about reasoning and all of the I don't think O1 had happened yet, which is pretty funny. I think for a brief intro, Ross was a co-founder of Papers with Code, and that brought him to Meta. And then at Meta, he was a lead on Galactica, which was a kind of language model ahead of its time relative to ChatGPT. So if people don't know about Galactica, it's a great paper worth reading. And then he was doing a bunch of stuff on reasoning with Llama related to a lot of the techniques that we'll talk about in this. And now he's doing a startup. I don't know if he wants to talk about this, but generally, we talk a lot about various things. This got started through O1 and trying to figure out some of these scaling RL stuff. We started talking a lot, but then we also just resonate on a lot of topics on training language models and other fun stuff, and trying to be one of the few people not in these big labs that tries to talk about this and think about what the heck's going on. So we're going to kind of roll through a long list of a lot of things that Ross sent me he wanted to talk about, but these are really just a compilation of the things that we've talked about and just kind of flesh them out outside of the Signal chat.
Yeah,
So Ross, if you want to introduce yourself more, you can, or we'll just kind of start talking about news because I think a lot of people already know you.
yeah. Let's get into the news. I think there's lots of fun things
What
to
do you
talk
think of
about.
the last 2 weeks of Chinese models? I think we had Z.AI's GLM 4.5 today, Kimi 2 last week. I think Quen is on a roll. It's like, what is the summer supposed to be chill, but this is crazy. It's like I haven't even used all of these. It's like the pace is just incredible, and all the open models have actually good licenses now. But is this going to actually hurt anyone in the U.S., or where do you see this going in 6 months?
Yeah, so yesterday was like the one day I actually tried to turn off Twitter. And then, yeah, so when you told me in the morning about the Xinhua like new model, I was like, okay, I had to read up on that. So that maybe that gives an idea that, you take your eye off Twitter for 1 second, then you're like, I don't know, 2 months behind on open source. Maybe that's an exaggeration. Yeah, I think the general theme is it's just been absolutely relentless, right? So again, thinking about the last time I spoke to you on the podcast a year ago, Llama 3 I think was a fairly like established standard. Looked, I think there was things happening in the background. You paid attention to things, but now it's just like absolutely relentless. I think the thing about particularly like Chinese business culture is as soon as they find something successful, they're just like very good at concentrating resources and going after that. So I think we see a highly competitive space. I think the context is very interesting on like different dimensions. I mean, there's the geopolitical dimension, which I think you've hinted at in some of your blogs, and like, what does this mean now if like the open source standard is Chinese, right? What does that mean if we think about these models not as like just things which power products, but as like infrastructure? Then it seems like China has a great advantage if they want to like be the standard that for the whole global South, right? But there's
I
also,
think
I
there's
think,
yeah, there's
yeah,
a few things that we're going to come back to in this conversation. It's so interesting. We're going to roll into our what the heck does it take to train these models, and we're going to talk about like
yeah.
how crazy and political and hard it is in the US, but we have all these orgs popping up in China, which is like, is this just like partially a US problem? But then we also have OpenAI that's supposedly going to release a model. It's like there's multiple things. I think
Yeah,
we'll
there's so
talk
many
about the
ways you can
training
take that.
dynamics later, but it's like,
Yeah.
why is like China is just really are they well suited to training these language models when we talk about politics later? Like, is it
I think
that
it's more,
easy in some ways?
yeah, I don't want to make like generalizations because I think if anything, what we've seen is like actually a lot of these new Chinese orgs are actually good at some innovations, right? I mean, just this week we had
Oh yeah.
GSPO, which was a nice innovation. But I think that the general sense is that once something is established as like a successful thing and like the specification is essentially just an engineering problem, then traditionally like Chinese based orgs, the culture is just very well set up to do well in that. The other dimension I think is now, especially after DeepSeek, right? So the Chinese government traditionally has been very good at like recognizing what's successful and allowing pouring resources in, especially with things like private, like public collaborations, right? So like I think that the conversation I saw on Twitter this morning is like, okay, so Xinhua has their own like state-of-the-art LLM. Like, why doesn't MIT have their own like
Oh,
state-of-the-art
this is kind
LLM?
of contrived, but yeah.
Yeah, I mean, so I think the US will wake up to this. But yeah,
My
it shows.
understanding is that Xinhua is or Z.AI, I think Zipu, I don't know how to pronounce it, is a startup that like spun out of Xinhua. So it's like I don't know if that's like the best
True.
comparison,
Yeah,
and
they
also
yeah
like Alibaba's the clear winner here because they have Quen, but they've also invested in Moonshot, which is Kimi, and then I think also this Z.AI. So it's like
yeah
um, I'm more interested in the question of like why, like the question of why they're all open is way more important relative to the talent because there's universities that have model orgs spinning out of them in the US, surely, but it's not all of them, and it's surely not all of them in China. I think MIT may do it. It's just there's a lot of like
yeah.
there's small numbers that we're dealing with in that case. But it is a thing that I obviously agree that the US should have more compute deployed for academics, and a lot of the universities are just spinning them up. It just takes a long time. So I think it's kind of there's a lot of mixed things there that are easy to draw.
Yeah,
Like and potentially like there's a good tweet in it, but I don't think it'll be 100% true, which makes for a very
yeah,
viral
yeah,
tweet
yeah.
when it's like it feels true.
I think there's definitely a naivety about like how things are actually working, right? And there's asymmetric information. You don't know what's going on the inside. I think the other thing is like, I mean, maybe this is a separate topic, but it's like I think there's a tendency to view open source models as this like homogenous category, right? But then there's actually very different use cases, right? So yeah, if I want to do like I don't know like a new reasoning paper, I'm going to use a Quen model, right? But then if I'm doing distillation, I'm going to use DeepSeek or Kimi. I think that fits into the OpenAI question because in my mind, I mean, we'll see. I'm sure it'll be like a great model, but I don't quite see how it would fit into the ecosystem, right? Because is it going to be something that people are going to build research on? Like, if it's a post-trained model, probably not, right? And then, so then you're thinking,
Yeah,
oh,
their
okay,
tweet
is
was
it for
about
like,
safety, so I doubt they're releasing a base model if they're like
yeah,
if they
yeah,
delayed it for safety. And I do think that they actually did delay it for safety. It's very in OpenAI's culture, but I don't think it's going to change the ecosystem. But it's like an interesting
yeah.
one-off because I also don't
But then,
expect them to release a model that's based on their GPT's 3.5 or
yeah, for
later
sure.
architecture. I bet they like took an off-the-shelf architecture, which is actually probably based on like Quen or Llama. So like a lot of the recent Olmo models are like very Quen-y, and they're like you choose the sizes based on what fits on the cluster, and I think Quen is very deep rather than wide, and it's like Olmo
Yeah,
2 is very similar to that. So it's like I bet the OpenAI model is probably also going to fit that mold, which is pretty funny.
I think so, yeah. I guess one way to think about it is they're just trying to distill their RL infrastructure into like white space, right? As opposed to make clear their architectural choices like in the public. But then,
But
yeah,
but
coming back to it, like, do you think? I mean, maybe it's a question for you, Nathan. Like, do you think the latest OpenAI model is like more comparable in its use case to like a Kimi or a DeepSeek, or is it on the Quen level, or is it actually something completely different where it's supposed to be, I don't know, like
I
an
expect it
on-device
to be
model?
smaller. But I
Yeah,
expect it to be smaller. They joked about on device, which I don't know is the right framing. But
yeah,
I'm also just realizing now if like RL is their great strength, part of the challenge of shipping an RL model in the open source is that you need your training infrastructure to match the inference infrastructure. So it's
yeah,
like unless they train this on like exact VLM that people have access to in some weird like open source environments, like they're not going to be able to just dump this and say like, oh, you could do search and code execution in your open model stack. It's like so there's so many
yeah.
weird things like that. I don't know exactly how Quen and DeepSeek have gone about it. My impression is that they're actually not as useful in terms of um, tool use because it's so hard. Like, I think that tool use is naturally a closed model reinforcing thing because it just benefits to have these tools match up.
Yeah, so what I've like seen, the Quen models are pretty good at things like function calling and stuff. But I think it's a more recent thing. So Kimi, at least on the benchmarks, was like pretty good at these kind of like agentic tool use benchmarks. And then, I mean, this is a separate discussion, but they had this nice like training uh, innovation, right, where they just got all these MCP servers and which is a nice synthetic data strategy. But yeah, it depends, right? Because you're just seeing mostly like headline evals, which you shouldn't really trust anyway. So
I think of Claude 4 as the one that kind of ended the
yeah,
eval chasing. That release was like on paper was so lame, but like it delivered for everybody, which is very bold, honestly, for Anthropic because
yeah,
there's a lot of money on the line. They're constantly fundraising. If one like fundraiser gets spooked because they're like, "Oh, your numbers are bad," like It's a lot of CEO calls they've got to make up.
I think I was thinking about this a few months ago. It might have changed now given the pace of AI, but I'm thinking like, what's the timeline for your impact for a release, right? So day one, it's just like, to be honest, like the bullshit benchmarks, like, oh, I've got like this amount on MMLU Pro, but then the next tier is like the day after, where people have got all these like weird bespoke evals on Twitter, and then it's like, I don't know, like
The pelicans and the rotating hexagons with balls in it.
and then you're getting more confidence because you're like, unless they're very smart, which I think some of them are, by the way, they probably haven't optimized for like the day two benchmarks, right? But that's when you're beginning to believe, oh, actually, like maybe this stuff actually generalizes, right? And then there's like the week or 2 weeks where you have like the real, okay, I've actually tried this out quite a lot now. It's actually like, yeah, very good. So yeah, that's the timeline.
Yeah, refute my claim. Chinese providers are still optimizing for benchmarks more than OpenAI, Google, and Anthropic. It's like it feels so obvious to me. I think that like China has closed the gap a remarkable degree, but I don't think they've caught up fully. I think that's hard. It's just hard to get all of that data and pipelines in place. A lot of it is actually, I think, user data and know your user, and then hill climb on that. So like all these APIs not working is a huge issue for them.
Yeah, I think they've been helped by the fact that the reason they haven't been quote unquote exposed is that, imagine you're an academic, right? And you're doing a reasoning paper. You can do stuff where data is available, like math and code, right? So you're already in that kind of basin they've optimized for anyway. So therefore, you're not, even the stuff which kind of reinforcing Quen use is not really necessarily like testing the true bounds of the generalization of that model, right? Because we already know that the Quen models are like heavily mid-trained on math and code. So like we're not, really exposing it maybe to some of the tails which are more interesting.
Yeah. Okay, this is a good preview for the episode. I think that we've covered the main things are definitely going to be this training organizations and then like so-called academic reasoning research and how to bridge that. I think we can start with this org chart, essentially the org chart question. It's like, how do you make a good org? Oh, or there's two things. One, how do you make a good org chart for training language models? And two, how do you make an effective culture? I think this is quickly becoming one of my favorite little niche interests because there's just so much intrigue in the person side of it, like as an individual. There's just so much money on the line to break everything. So you sent me some hot takes if you want to read them, but the floor is yours for what does and does not work.
Yeah. So I think I've just been like, I mean, if anyone's been on like social media, the general trend has been you check social media, then you've seen these like kind of like NFL draft style tweets of like someone's being recruited by an org. Like, first of all, like researchers have always moved between orgs. This is not like a new thing, and a lot of the orgs that were hyped were just like regular moves. But I think there's also just a general tendency just to see like the bottleneck in a lot of LLM projects, at least on Twitter, has been like kind of skill issues, and at least from my like n=1 experience, that hasn't been the case. And I think there's a number of ways to like make this case, but I think I'd start by saying like, machine learning is just a heavily empirical science, right? So like, what does genius even mean in that context, or talent actually mean? And there's certainly some skills which are useful, like how do you form like the right, minimal viable experiment? Like how do you iterate, fast to, through a research direction? We're going to hit dead ends. But a lot of it, to be honest, just comes down to like hard work, good infrastructure, and like resources. So in that context, like, to be honest, like most of these orgs, even before like, certain public like failings had like very good people, right? So, and I don't think the difference in talent between different orgs is like that big, to be honest. Like, it's just like, smart people eventually figure things out eventually. So then more often than not, like you see like the difference in like, let's say a good model versus a bad model, it's actually just reflecting some inefficiency in the ability to kind of channel resources to your talent, right? So I think that's the fundamental point. Now you could say on the flip side, okay, Ross, well, if that's true, like why is Zuck paying people these like massive amounts of money? And I think that's a separate question. But yeah, more often than not,
what do you think?
Yeah, so I think. So I'm kind of torn on this because on the one hand, I think like their new group will probably like make very good models. Like I think yes, they're like very smart people, and I think having a new org as well, I think is the right way to do it. So I think in the leadership's mind, it's probably just a case of like, look, we tried this multiple times. We're very serious about this. We have resources, so let's just do like the maximum conviction play. And I think that's like broadly what you would do, because it's still like, I mean, it's big expenses, but it's still not like, a massive
Not that
amount to spend,
expensive.
right? I mean, so I think that's going to work. But on the other hand, I do feel kind of sorry for like, this isn't a meta point, but in general, like I think it's a shame that a lot of the organizations don't have good mechanisms to already identify the talent that's in their orgs, like doing the hard work, and then they need to do things afresh. I think that's the kind of tragedy of it. Um, but yes, it's kind of that conflict is in my mind. I think they'll make great models. I think it's the right approach to do things afresh. But at the same time, it's a shame that all the people who grafted on previous generations of models sometimes are just treated a bit like an asset, right? So you've used them, you've kind of like worked them hard, and now you move on to like the new group of like people, right? So I think this isn't just a meta
Yeah, you
point,
put
but I
this
think it's
in.
a yeah.
You put this in your provocations. You sent me that that language modeling labs are sort of like banks where people are slotted in to burn out and burn through. I mean, I know a lot of the work that needs to be done is somewhat mundane data work, and it can be parallelized if you're like, our users are asking this type of question. Let's create new prompts and manage human workers and create synthetic data pipelines for this one thing. And it works a lot of the times. What is it like? The Dwarkesh has these podcasts with Sholto and Trenton, and it's one of the one that works. They've both moved jobs, which reinforces your point. But they're like, oh yeah, you just need to convince someone at a frontier lab that this problem is important. So it's like people talk about this, so you just have to do this. Do you see a lot of people being dispatched to solve these specific things versus the dynamic where the individuals are kind of a free reign and it's fun on the ground and you choose the things you want to add to your beautiful final model? So you can present a positive and a negative. It might vary across labs, but I guess your provocation is that there's a bunch of places where it kind of is a like a meat grinder, and you just put people in and chew through them.
I think so. I think like a model for a lot of, unfortunately, like a lot of successful tech companies is just you get very young, like motivated, definitely base level smart people who just are willing to work very long hours on like a strong mission, right? So that was like the original like Elon way to run a company, right? But I think that's the model for a lot of frontier labs, right? You have your soldiers who are the ones like who traditionally like look on the surface they look like quants at like kind of hedge funds like 10 years ago who are just going to like work incredibly long hours on something that they think is impactful. You have a culture of like kind of friendly competition where everyone wants to be the best,
I
right?
will say I know a bunch of people at OpenAI, and they do work crazy hours.
Yeah.
It's
um
like I
yeah.
also work a lot, but I do a lot of things that aren't grinding data to go into the model. I do things that I think are at least partially fun.
Yeah. And then I think the decisions are generally made by like people who are a little more experienced or at least have like some successes to their name. But yeah, you need to have soldiers in these kind of climate, right? It's just highly competitive. And I think that's a shame. I think, at least because even for myself now trying to build a startup, I'm trying to think like obviously we need to work hard, but like is there an alternative where you kind of invest in your employees as like kind of using them as burning them out and then moving on to a new
Well, this is
new
the
churn? That's like what I'm trying to
this.
work out for myself.
I feel like a lot of people are just kind of more cynical now in tech, myself included, because it's like I got a great cold email from fresh out of undergrad, and I was like, I'm pretty sure in 2 to 3 years this person's going to be super legit. And it's
Yeah,
like I would tell a coworker about it. It's like, what do we do to like how can we capture that? And they're like, oh yeah, well we do it anyways. They'll go to OpenAI in 2 years, so we don't get any of the upside. So I think some of that is just kind of cynicism, and investing in people is still the right thing to do because you'll end up keeping the ones that are a bit more grounded, even if it's really hard. I mean, I've lost people that are extremely talented that I would want to keep. So I don't know how to balance
yeah,
that cynicism versus reality of building teams in the
yeah.
long term. I would
And I
guess
think
smaller teams might be a bit easier to maintain, where if you're at a tech company, the churn is kind of impossible to
yeah,
prevent for a lot of because there's so many levels and moving up. I think a lot of rumors of meta, like especially around Llama 4, was just like, I mean, Dylan Patel of Semi Analysis, we can find the quotes from that. He was essentially like they were doing the most cowboy crazy model training ever, like changing the pre-training mix halfway through, and that points to like middle management being like, I need to use my data so I get my promotion. But most labs I don't think are doing that type of shit on their leading models, and I don't think Meta is normally doing that. I think that was a pressure cooker side
yeah.
effect, or
I
like
know, but I'd
Oregon
push
floated
back. So I'd say like I think actually in a weird way, like all of these labs, at least from what I've heard, are like deeply chaotic places. Like they change direction every week, right? I mean, that's just the nature of the field we're in. Um, and I think, but then maybe definitely certain labs are good at projecting, like at least externally, that they have their shit together. They have like AGI internally, like all this kind of bullshit, right? But the truth is, it's like a shit show everywhere. It's just that if you're going to be a shit show, you at least want to be like a functional shit show, and you want to make good models, right? So it's like, so I think, but yeah, I think there's definitely plays to be made about, do you take the view that you want to like invest in your talent more as opposed to just like grind them out? I think if you're a startup, you don't have a choice because you can't just grind out your employees if you don't have like 10 of them, right? But then there's also in my mind like, yeah, especially in like I would say like kind of lab culture, I think people tend to overvalue just like raw talent again, especially in empirical science. So again, if you take the view that an empirical science is mostly about like experimental velocity, then again, not just you don't just like value infrastructure in that world, you also just value like, okay, I want to hire someone who's just like very collaborative and is like very willing to help other people out, right? It sounds like a
Like
bullshit
a high
point in a
agency
field.
person.
Yeah. It sounds like a bullshit point in a field that like lionizes like individual intelligence, but I just feel like if you're making a marginal hiring choice, like how does someone like add to your existing group, right? Are they gonna? Yeah, that's just like a. And I think these things are actually undervalued, just because I think it's all just now in the minds of people. It's just about like, okay, find the smartest people who are going to like be super cracked, all this kind of narrative and stuff. So yeah, I think there's new plays to be made on talent, um, but it's difficult. There's nuance because like don't get me wrong, that there are people who are like especially productive. Like I've seen it in person. It's not like everyone's like equal. That's definitely not the case. But it's just like I feel it's yeah, individual talent is
I think a
overvalued
lot of
compared
the
to
a
yeah
lot of the
team.
differentiation right now is honestly just people who are willing to put more highly focused hours turning the crank. I think
Yeah,
there's every organization has this baseline of um, the cost of being there in terms of meetings, whatever your life is. Maybe you have to live somewhere where you have to commute or something. But then it's just like, in terms of AI, unfortunately, it seems like the people that do more and more, they just have a bigger fraction of time actually spent doing
yeah,
stuff as well, which is it just favors young people that don't have a lot of responsibilities.
yeah.
It's just
But
kind of
I
like,
was, but this is maybe a transition onto another point. But like maybe I'd make a more controversial point, which is that even in the things in ML which seem like more in the realm of like doing novel research are just like you can also pitch that as a form of just like persistence as opposed to like inspiration, right? So take like this time last year we were both speculating about like what O1 was and strawberry was, right? And then speculation like tends to make you think it's like some amazing new thing, but actually when you looked at it, I mean, it was what you were basically doing and what I was doing like 2 years ago, right? It's essentially just like RL on verifiable rewards, but with like probably a very good base models, right? Because they were in a good position to do it, and B, enough ablations to find like a mix that worked, right? So, and I know
probably a
that's like
lot of data.
oversimplifying after the fact, but like just take the view that they had to do the work to make the recipe good. Like it just comes down to experimental velocity, right? And then also having the right infrastructure and a good enough base model. So then in that world, like what is talent, right? Is talent like the person who says, oh, we should make the models think more? Or is talent the person who actually is actually on the ground, like doing the ablations to find out which recipe works, right? Because I can also make models think more by doing best of n, but obviously that's not a very good way to do it, right? So,
Yeah, I mean, I
yeah,
think I analogize a lot myself with my athletics career. It's like rowing in college. I think so much of it is the same. It's like I wasn't the most gifted athlete, but if you put in the hours and you're like understand where you're spending your effort, it works out for people. So a lot of
yeah.
like it's like the super talented person that's doing this like complex like N of one research perfect YOLO run is like okay, the other person that's just hill climbing and data will win out. I think the
Yeah.
question that I want to ask you on this topic is, given that these orgs are so chaotic, what does this mean about the ceiling in progress? So one of the most coveted questions is, what is the trend line? I think there's obviously going to be new paradigms. I think inference time scaling was actually a quite obvious one if you were to look at first principles of what compute and intelligence is. But even if we don't have a new paradigm, like what is the ceiling? If there's so much chaos, I'm biased to think that the ceiling is not that close.
I think it's interesting, right? Because I think even in climates which are like organizationally chaotic, you're still going to have things which kind of, lift all boats, right? So like a good example recently was like, these like gold medal results in like IMO, right? So I think it was like three different labs all had different approaches and found they crossed the threshold, right? So if you were to zoom out, and one way to do this is imagine you're looking like 20 years into the future back at this time, right? Like, would you look at the individual methods that these researchers did, or would you just say, oh, they just like reached like a critical threshold of compute where things start to work, right? So I think compute is like, unfortunately, that's like the big like kind of exponential that's like underlying all of this. And then in our kind of like, if you zoom into like a shorter like time horizon, then you're getting to things more like, okay, what's the current challenge? Like, what's the bottleneck, right? So maybe the bottleneck to, I don't know, agentic models is like RL environments, right? Or maybe the bottleneck to reasoning, even better is like longer context windows, and that's like the smaller term things. Um, but yeah, fundamentally, so long as like compute continues to increase, like I think the trends look good, and then all this kind of like organizational stuff is just like short-term noise, which slows down progress a little bit, but it's not that meaningful in the long term. But unfortunately, it's still meaningful for people in their careers because, like, okay, 1 to 2 years of like organizational chaos or whatever is could matter, but on the bigger timelines, it doesn't really matter.
Yeah, I mean, I agree. It seems like the question is what happens when the fundraising starts to slow down.
Yeah,
It's like we're on a trend line of compute rollout, and then if Sam Altman can't raise again, that is a very big sign. That's like the end of the quote unquote bubble. And OpenAI is not going to go away because of that. But it's just if OpenAI can't get the next cluster that Google is using, and that's where it's like
yeah,
we can't make arguments on if it was some miracle until Sam Altman can't raise anymore, because otherwise Google and OpenAI are going to be doing effectively
yeah.
squinting the same.
I mean, I'm quite optimistic because I think it's just like you only have a bust if this like AI like ceases to be useful, or at least the promise like it doesn't live up to certain promises. But I don't, even if there's no algorithmic progress or no, I still think AI is going to continue to be increasingly useful. I don't think there's any fundamental barriers. It's just a question of like how quickly like you get there, right? I think that argument would have been slightly different 2 years ago because if the reasoning paradigm didn't come through, then I think it would have been trickier to justify some of the expenses because then you'd be looking at like benchmarks and reasoning, thinking, oh shit, like to push this forward, I need like this amount of data annotation or I need this amount of new
Yeah.
data.
You look at GPT
Um,
4.5 is the example.
Yeah, exactly. That's a really good example. So that's like almost like a counterfactual universe where reasoning didn't happen, and we're all looking at this and saying, okay, it's good at creative writing, but then okay, it's not really doing the, the things we would
It's
really
not
like it to
that
do.
good at writing. It's
That's
like
sorry, I don't.
intangibly
Yeah,
better.
I'm sure that's a really good model. By the way, I didn't really play with it enough to find out, but it's more the general.
I've been using it a lot. Like I use GPT 4.5 for a long time, especially until Claude 4 is kind of like it's just nicer, especially when GPT 4.1 was so sycophantic. I was like, I can't use that. But GPT 4.5 was still it's interesting in a way like that, like different models didn't really have it for normal stuff. If you're just asking about any random thing that a language model will know about, some
Yeah, yeah,
stupid
yeah. It
dogma.
had a good vibe.
So I think it's a quite good model, but it's also just such an interesting release of the
Yeah,
history of where AI was going.
yeah. So I'm
Um,
gonna flip it around. I have a question for you, Nathan. So like, let's say we're here in a year's time. Like, what does the key benchmark look like for LLMs that everyone's focused on?
oh,
So
it's fully going to be some like agentic thing. I don't know if it'll be as stupid as how much money does it make on the stock market when it's doing it. But I had written this post of like what comes next, and I think one of the most poignant things I was looking at in this is just scaling is not really the path that models are taking anymore, and it's like all the marketing is shifting to agents, and I think some of that is just because it's not easy to scale parameter size anymore. Scaling RL is happening, but not going to make these. We've taken every RL curve is this log plot, and we take the first log of the performance, which is like 90%. So it's just hard, but the agentic things are working so well. So we have Claude Code show up
Yeah.
And there's going to be that in all sorts of domains and more people working to evaluate it. So I think it's like an interesting marketing problem at the same time, where all the labs need to refigure out how they communicate that their model is so good. Like Claude 4 didn't do it. They
Yeah.
didn't land that, but it was good, so it was
Yeah,
okay.
exactly. Yeah.
But everyone needs to like switch this narrative. It's just like all the model sizes, GPT-4, 4, and then it's like 4.1 mini and nano, and then Gemini Pro and Flash, and the Claude Opus Sonnet. Like all these things are the same size classes. Like if they really 10x'd in size, they would give it a new name. And I think that'll come eventually, but in a few years. But I think it's all on this agentic side, which is a big shift in what the language
Yeah.
modeling companies need to think about. And it's like the prioritization of the company is also different, where it's like the modeling has always been the central for us. And I'm still like modeling pilled. So I still think that that is the most important thing to the company. I think that I say that's the most important thing to AI too. And like these open models, just because AI 2 can offload who is building products and agents on Olmo to the rest of the academic community. And like OpenAI can parallelize this to many teams building products. But these sub teams that are building products are going to hold more weight than they used to.
Yeah.
And there's going to be more interesting kind of like how these companies manage it and do comms will change. So I mean, I think Claude Code is great. I think that it's hard to integrate in some things. Like it's how do I get Claude Code running on our cluster at AI2, where we have all of our like data and models and want to launch evals from our our file system on the GPU machines. It's like I don't think I can install Claude on that. Maybe I'm doing something wrong.
I think it's
so there's stuff like that too.
Yeah, I agree with your answer. Like I think the way I see it, so there were several years when I was doing like papers of code, which tried to like focus heavily on kind of evals before they were even like a big thing, trying to index all these leaderboards and stuff. And I think now's an interesting situation because I feel like if you make good evals now, you possibly have like more leverage than you've ever had like in the field of ML, which is a weird thing because traditionally evals were quite an unsexy thing to do. It was a thing that researchers didn't want to do because they'd rather be training models. But now the ability to define like a metric, like you said, which maybe gives some leverage to products, but then also just like a capability that you'd like to see, whether it's like, okay, the model is good at like trading stocks, right? Or it's good at doing scientific research, right? I feel that's like there's incredible leverage for like a small group of people in like even like universities to say, okay, this is the new like North Star that we should try to achieve with agents, and then like take control that way.
It can happen.
Right now,
I mean, we released a like an IF eval replacement, which is like IF bench, which is just more constraints, like a different prompt sourcing. It's just like a harder IF eval. And then I was like, okay, we need to make the goal of having the two of the frontier labs to adopt it because then everyone will.
Yeah.
And it's like I message people, and it's like I messaged someone at OpenAI, and they're like, oh yeah, I did that last week. And I was like, like who else is making research that is like actually has a shot of getting into the OpenAI internal platform?
Yeah.
It's like
exactly right. Yeah. So it's incredible, leverage. And then I think the other interesting thing though is like the friction to actually using good evals is just going to increase like quite a lot, right? So even like some of the stuff like recently, like ML scientists, like kind of ones like Emily Bench and Paper Bench for some of the OpenAI ones, like in the case of like some of these benchmarks, you need to have like the RL agent needs to have a GPU available, right, to do ML research, and you need to like spin up, lots of servers for RL to. So I think it's long gone are the old days where you just have like two CSVs or whatever, which is like a train and a test split, right? So that's on like the user side, but then even on the eval creator side, like there's a big difference between, especially as the models become more capable. Like a bad eval just means that you're going to get like incredibly egregious reward hacking, right? And you're not going to learn anything useful. And a good eval is like the pathway to a new capability.
So I have a related question on this.
Yeah.
So I see three eras and evals in some ways based on what people are doing with models. At pre-training, the best evals are testing knowledge and these very broad things, and they're hard to game. It's just kind of like flops.
Yeah.
At post-training, a lot of evals is actually formatting and extraction. I think formatting became even clearer to people when these RL environments became the hot new thing.
Yeah.
And I actually think that post training might be like the ugly duckling in the middle, where then if you go into agents, like all the agentic tasks are going to be evals of actually doing anything, and you can't like format lie your way through that. So it might be that like post training evals are like actually the hardest one to get right.
Yeah, and I think you're going to see more cases of like people claiming like good results, but then when you look at the actual surface, like absolute like insane reward hacking. So the meme right now, I'm not sure you've seen, is like the kernel bench evals. Have you seen these?
Oh
So
yeah.
so you have like these amazing speed ups, which like yeah, first of all aren't even like popular given like basic like information on the configuration of the hardware, and then yeah. And it just goes to show, even to like that's not a problem with kernel benches. I would say it's more a problem with people like publishing the papers without looking at the results. But just to get an eval in the right place for like a task like that is actually like a lot of work. And even with the progress in models, like I don't think you're just gonna be able to automate the construction of a good eval like that, at least in the next year. I might be wrong. They'll certainly help. So I think yeah, that's an area which is just a lot of leverage right now. I mean, I think if you were to ask me at the top of my head, like what is the central eval right now, it'd probably be something like SWE bench verified, but even that is like, in my opinion, quite saturated. So there's like a big, blue sky that someone can like define like what the next like task is for ML, and actually that doesn't need like a
Yeah.
big cluster to define. So I think that's quite an exciting thing for
Yeah, and when you think about the amount of money that'll be steered by these things, it's so crazy to have the uncertainty there, and like who will come up with that. It's wild. I think that it's part of what makes it fun. I think the pace is obviously fun, but having more people actually contribute is good. We should talk about reasoning things.
Yeah.
Where do we start? I don't think I've ever done like that mean of a rant about the academic community chasing these things for a pretext. I understand why academics individuals are doing this, which is new algorithm, something that is in well-established systems showing remarkable scores. But a lot of these papers are just kind of extracting things that are hard to document from a model or something else, or formatting or something like this. So I mean, I was on one of these papers, which was hilarious. It's just like a very you like figure out that you train Quen on random rewards, the evaluation will go up, and you have to like go through the logic of how can this happen, because if there's no reward, the advantage is 0 and the gradients are all literally 0. And then it like turns out that the algorithm manipulates the most common sequences. Is actually something, if you read a lot of the reasoning literature, like people talk about like, we want to make sure our algorithm doesn't squash these uncommon sequences. And then like the real hammer is, if you do random rewards, like literally the model just kind of has modal collapse onto the things that it was trained on. Like, and that can make scores go up. So it's like, if you have a model that 2/3 of the time has a certain behavior in its reasoning, and that behavior is good on the benchmark, if you just fiddle the weights a little bit, like sometimes it does that more, which is just like that. It points to a somewhat structural failure, and I would also say like a good example for why people should be using like truly open models for research purposes, and why they're so good for innovation, because it's like all these great human hours. If we knew what goes in Quen data, and if someone just filtered it and it was like, oh look, I found the GPQA prompts in it, it's like data contamination happens. It's not necessarily, the Quen case is borderline. I don't know how exactly to characterize it, because the Quen models are fantastic, but there's so much research that is showing that they are very likely to be doing some dubious things in terms of benchmarks. It's like, it's hard for people that aren't super in the weeds to hold both of these in their brains. So I don't know. What do you think of the last 6 months? Have we actually made any progress? Has the academic community made any progress?
I think there's been like little progress, in the literal sense, little progress. There has been some progress. Yeah, I think you can answer in different ways. So I think after DeepSeek came out, there were two, at least, approaches in open source more generally, which was either you go down the kind of distillation routes to make interesting small models, or you go down the RL routes. I think the initial thing that was kind of undervalued, at least from a practical engineering perspective, is that if you're dealing with smaller model sizes, it's just like way more efficient to do distillation than RL. But obviously, from an academic perspective, you want to do the RL. Then
you mean it in not just in compute, but also in performance. It's like it's hard to do RL on the small models.
I think that point's been made twice now. So it was an original DeepSeek paper, and then more recently there was a Quen paper as well, which I think the Quen paper showed that the RL was like kind of 17 times more compute. So one way to think about that is that RL really is like a brute force lever to do data like generation. But then, okay, assuming that RL is still good, that you want to be able to do research in academia, I think the difficulty is like, it's just a classic problem where if you don't have enough compute, you don't know what structure you're imposing is going to generalize. And my worry is that a lot of the kind of results are like relatively low compute budgets, both in terms of like the underlying base model, which determines like how well the RL kind of approach learns, but then also the number of steps. So it's just quite hard to see, unless there's like a massive gain, what's truly important. So like the most useful things are actually, in my opinion, quite boring things. Like, there was the DAPO paper where it's like, okay, we shouldn't, the filtering for overlong sequences, we shouldn't like bias that. I think there's been some interesting stuff showing that maybe even kind of simpler approaches in GRPO might work, where you don't have the clipping. So Rekka was doing a lot of good work using like kind of reinforcement learning, leave one out. But even there, it's kind of dubious because you just don't know, is that algorithm going to generalize to like agentic traces, right? So it's not clear. I think the recent stuff actually this week was quite good. The GSPO stuff, I think that was like well theoretically founded, and then if you saw their graphs,
can you explain it to people? I think a lot of people have heard of the other ones by now, but like GSPO, I think is group sequence policy optimization.
Yeah,
from Quen Coder. Why are you positive on it relative to all the? The algorithmic ideas are well motivated, but like why is GSPO actually getting hyped more?
So I hope I don't botch this because it's the morning, but essentially with GRPO, you essentially assign like a reward to the whole sequence, like your advantage, but then you have this kind of importance weight, which is like your kind of like policy kind of likelihood, and then the old one, because when you do RL, you typically sample lots of rollouts, but then you do several mini batches. So that means in practice you go a little bit off policy. So to fix that, you just have this like kind of like term, which is like an importance weight. But then with the importance weight, while the reward is applied to every token, like kind of uniformly, the importance weight is for each individual token, and it's from a single sequence. So like you're just like looking at like, one way to think about that is your importance weight. If you had more sequences, like it would be like more accurate way to reduce the bias. But actually, if you're just doing it on a single sequence, it's actually introducing a lot of variance. So essentially, the short answer of what they do is, instead of just looking at like a token likelihood, they look at the likelihood of the whole sequence. So now the clipping is not like on an individual token basis, but actually it's looking at like, let's say, one of the sequences in your group and saying, okay, this is like less likely, we'll just like not look at that sequence. And the TLDR is that, at least from the results they show, it seems to be a lot more like sample efficient. I mean, it's not just like a few, 0.5 percentage points or something like that. But I think the reason I trust it more is it's very simple, and it seems to be like quite theoretically well motivated, just from basic like understanding of importance sampling. If it were more complex, I'd be a lot more skeptical, but it's fairly simple and seems to work.
Yeah, I mean, I'm still fairly skeptical. I think all of this is that once you're like on a narrow, we can think about the academic research as being relatively wide in what people are trying right now, and the labs being relatively narrow. And when you're further along in your modeling journey, you're dealing with different parts of the state space, and then these algorithmic tweaks just like help your model on whatever blocker it was or your implementation. I thought GSPO, the sequence thing, was so funny because when you read the GRPO paper, you're like, oh, the reward is just per sequence. Like all the tokens in that sequence will get the same loss function. But the standard implementation is to break it down per token. And then this GSPO is essentially to take that standard implementation and you change the weightings of every token back to this. And I was like, is this really going to be a major, it's a cool idea. And I think especially for junior researchers, I think one of the good things about this era is that you can really learn the math by studying all these algorithms and thinking about what they get implemented like. I hadn't done that in a few years, and that was me writing this like RLHF book on policy gradients. It's like, oh boy, like why the heck is it length biased if you're doing a per token loss and instead of in GRPL? Like, why is that like what? And it's like, it's the fact that you have like these normalizing factors, and if you have if you have these per token probabilities, those are going to be roughly similar, but a longer sequence has a bigger denominator when you're length normalizing it. And then if that's your loss, then you have a smaller loss, or like a smaller gradient or something like this. And for students to be able to do this in their brain, it is really, really good for thinking about the interface between algorithms and systems. But I'm team like GSBO doesn't really matter. Quinn had collected some really beautiful results on their infrastructure, because there's even like worries on like the difference between the gradient ecosystem and the inference ecosystem in the open. And I think everybody kind of has some of these worries. There's just too many things to nail down that I think nailing down exactly like what your own system is doing tends to create better models.
It's interesting. I think as AI became hyped after ChatGPT, and you just see like more people like reading papers, which overall I think is a great thing, by the way. I think you have more people like just reading papers kind of in the wrong way. I think for me, it's just like the basic logic is like how much, like what's the reported gain of the paper, and like how much complexity does it introduce, right? So if you get like a gain, but it's just like shitloads of complexity, it's probably not going to stand the test of time. Whereas if it's something relatively simple, but seems to like get a good gain, then that's like the thing that's going to last. So I think I don't want to be like harsh towards academia, because I feel
that's the O1 lesson.
The
simple
exactly,
thing with like O1. In RL research, I've heard it described as like if you see something that only beats the baseline by a few percent, it's not going to work. But if it's like 2x, if it's 2x, that's the real innovation, because like even if whether or not they fine tune their baselines, they're still crushing it.
Yeah, exactly.
So I think that's a good heuristic for people right now.
And I think researchers are their own worst enemy, because they want to see their own methods work. But at the same time, the weird thing in ML is like, neural networks, they want to learn, right? So it's like, if you push something enough, it will work. It's just a question of like, is it a good use of your time? So it's like, okay, what's the right thing to scale, right? So, and that's why, when you read papers, you just take the view that, just always think in terms of like, at least what I say to like younger researchers is like, okay, how much complexity, how much gain, and like, do you trust the gain, right? And then based on those three factors, you're like, is this worth reading? But I think that is, at least if like you're new to like reading papers, like sometimes it's easy to like see, oh, okay, this like new techniques look super cool or something, and it has like this kind of gain, and
papers aren't about storytelling, or they're not presented in a way that they are about storytelling. But researchers manipulate the results of their peer methods in the way to tell a story. So it's like when you are making a paper, you think about the story that you are being read, but also subconsciously researchers are manipulating their own results to make that story manifest. And I think these algorithms are a perfect example of it. So when you like kind of think about what is the word for this, when you're like not the mental model or mind map or something, but you think about the kind of cognitive behavior of the other side, it's much clearer. That you have to read a lot of papers and be chilled to do that.
And then I mean, in the reasoning space, the other point is just, I mean, everyone knows this now, but just I understand that people have to focus on math and code because that's where the data availability is. But I just think if a paper comes out and it's on like the Amy benchmarks and GPQA, it's just a lot less interesting like now than it was like a few, at least even in like February.
I think code can be much better, but it's hard to benchmark it. So like describing what a good coding model is would take me an extremely long document, but that's not what the academic papers are doing. I don't know how to do that. Like I would love to have more, like we need a whole team to hill climb on that.
And even the established ones, right? So I mean they're good benchmarks, but like SW Bench is like some ridiculous number, right? So I think I don't want to misquote it, but like it's mostly just issues from Django, right? I don't want to like
Yeah.
have that as a burn towards SWE bench because I think it's a great benchmark. But
They already won. They already won.
yeah,
They can
yeah,
take
yeah,
subtle things. Like they won.
yeah. Um, but yeah, it shows that there's still a lot of nuance like to making a good I don't know coding benchmark course or whatever. So it's difficult because I'm in this position where on the one hand I just look at the papers like just doing hill climbing math and code, and I'm just it's fundamentally uninteresting. But at the same time, I sympathize in the sense that like okay, what else is there to do, right? There aren't like a lot of great open reasoning data sets in the open. And those that are open, I don't even think that they're going to be good for testing RL necessarily. If it just tests something more knowledge based, like medicine or something like that. So it's a difficult
Okay,
situation.
this could be a good time to transition. Is like,
Yeah.
what is the status of RL scaling and generalizing? What is the status of RL outside of math and code? I think my
Okay.
my prompt is somewhat like, what do you think about three like models with this crazy search behavior and this
So
multi-hop execution?
yes. Okay. So first of all, I think like it was greatly overstated this argument that like it doesn't generalize beyond math and code. I think what happened in practice is that at least from what I know, like OpenAI originally they were very focused on math, logic, and puzzles and stuff, and then eventually they kind of had to broaden out because it was kind of too rational and focused on those kind of like benchmarks. But I don't think it was ever in question that it was generalizing to other benchmarks. You could see that very early on, and the reason I think about this is like we kind of started with math and code because it was kind of easy to verify, and then through that, like applying RL, it learned certain like strategies, like okay, I shouldn't just like answer early, I should check my work, or I should consider alternatives. And at a very high level, if you just have a model that kind of thinks for longer and checks its work more and it considers more things, and that's going to be useful for things beyond math, right? So, and that's reflected in the benchmarks. And that being said, if you want to get like to super intelligence or whatever outside of math and code, then yeah, you probably do want like specific benchmarks for that. And I think the question is less does it generalize beyond math and code, but like how well does performance like how good does it become, right? And that's when it gets you into more interesting questions about like okay, if you don't have a numerical answer or whatever, like how do you verify things, right? So rubrics are all the rage right now, but then there's also other directions like kind of like
Rubric things are so
rubrics.
funny to me to be reinvented. It's just like rubric is such a funny name because it's like
It is
behind
right.
a veil. It's like it's just question specific LLM as a judge. It's like the most basic unit of evaluation or
Yeah,
feedback.
yeah. So I think that was actually something that wasn't very covered in the open. So the reason why it became popular was that essentially like deep research was the trigger. Um, so the rumor at least was like they at least OpenAI they didn't actually need that much like examples in order to like kind of do quite well in these tasks. So it wasn't like tens of thousands of like rubrics. I think it was like probably like 1,000 to 2,000 like well crafted rubrics for questions. Um, but yeah, it's clearly like worked very well to teach a model like how to like browse the internet, right? Like synthesize knowledge. There's obviously like infrastructural detail as well.
What would a rubric look like for deep research in this case? Like,
Okay, so
I think of a rubric in like a general question of like, you can think of like, write me an essay on this, and then the rubric will be like, oh, this question should probably have be free of typos and have a clear argument and a good conclusion. Will be like different checklists. But I think
yeah,
the deep research thing is a bit more complicated to
you might have
like,
different
immediately
themes,
draw an
right?
example.
Yeah, so there's different themes you could have. It could be like okay, the general style of the answer. It could be like okay, let's say it's like we want like a review of like the latest like and greatest like RL algorithms for reasoning or whatever, right? So first of all, you might have something that's like more high level, like okay, it should maybe like have compare at least a couple of like methods, or maybe it should have a table comparing like okay, what's the underlying algorithm it's based on? Is it like policy gradient, and okay, is it PPO based or reinforced based? But then you might have like more detailed things where you just have like strong conviction on what a good answer looks like. Like, okay, right now it's probably mentioned GSPO, right? That might change. So it's essentially just like a list of criteria. But the goal of what you're actually getting is you're just trying to get like a nice continuous reward where the model can like gradually like learn as opposed to get something more sharp. Because you could, unlike math where you can have a zero or one reward for something like okay, what makes a good literature review on RL, right? It just the reward structure doesn't look like that. So
How do you think of grader functions and stuff? I think I've thought about this for code, which is like code you can do the percentage of unit tests that pass, but like
yeah,
a lot of times your model will just get the easy unit test then. It's like how like do you think reward shaping is kind of here to stay, or will it be washed away in the ever growing sea of compute?
I think it'll be washed away, but I think in the meantime, there's still a lot of value in like making very good handcrafted evals. And I hate the word taste, but like I think there is still taste like to begin with. And I think a lot of these things are quite codependent though, because okay, to make a good rubric for like a deep research task, then you probably need something that needs the ability to do like deep research, right? And like, okay, if we were to say, okay, what makes a good literature review on RL right now, it probably wouldn't be in the weights of a language model. It'd have to go out and like search for things, right? So yeah, in the long term,
You could tell it. You probably need to use search to answer this
yeah,
question.
yeah. If you don't use search, then you're probably doing the wrong thing. So yeah, in the long term, it gets washed out because there's nothing a neural network can't do if compared to a human. But in the short term, there's still a lot of like nooks and crannies that yeah a model wouldn't do very well on. So
Can you create a generative reward model by training off a bunch of rubricized data? So if
probably
you like,
yeah, I think
it's
verification
a
is
reward model is gonna go away.
I think
Are they doomed?
verification is also something that benefits from like thinking time, and I think most people are aware of this now. But it's just the question is like how you actually execute that, right? So I think a generative reward model for something like yeah math and code where it's like a 1 or 0 that's trying to figure out by thinking is less interesting than okay like how do I go about answering this question from first principles, right? Or how do I think in general the simplest way I think about it is like if you're moving to a world where you have kind of long agentic traces, like your quote unquote reward model just needs to answer a simple question, which is like is the agent making progress towards its goal, right? But that's a very deep question. So if it's like a Pokemon eval, right, and maybe it uses its knowledge of Pokemon to figure out, oh, the agent in this trajectory has caught in a loop or something, right, and it should be going this way to I don't know Lavender Town instead of this way, right? So there's yeah, I think that benefits from thinking time, but it's just yeah, the devil's in the detail because if you're not careful, you're just going to spend an inordinate amount of compute trying to get a reward. So
I do think there's going to be a lot more that we learn there. It feels
yeah,
obviously salient. I mean, um, I describe it as verification kind of changes the slope of inference time scaling. And that's really, really valuable if you're spending a lot on inference, but
yeah,
we don't really know how to do this. And like parallel compute is another factor that kind of
yeah,
changes the shape of that curve. I guess it's all a slope of a scaling law or like an offset or something, but it's hard to say things that are particularly um, true in terms of what we're hearing and what seems like something that you could tell somebody and like that's probably what they're doing. Other
yeah,
than this rubric stuff, which is just like getting RL to be able to be pointed at more problems, which is not that surprising.
yeah. No, I think rubric mania is in full force right now. I mean, I think the longer term question, which has been made in several places, is that okay, what happens when verification becomes like fundamentally harder, right? So um, I'm quite interested in like the scientific discovery things, but if it's something like biology, right? You actually need to do a physical experiment in order to verify, right? So it's not like something where you can just like easily run things and then okay, if you want to simulate the underlying thing, well, then you're bottlenecked by the quality of the simulation, and it turns out to be quite hard to simulate some physical processes. Actually, in most science, I think this is the other point I'd make, which is that in ML, I think people again overvalue the power of say thinking in something like science. They think of like an Einstein or whatever, and they think a lot less about what's the data generating mechanism, what's the instrument, right? So like there's no like Kepler without the telescope. There's no like you know progress in biology without X-ray crystallography. There's no like maybe new like theories on like dark matter in space without like better telescopes, right? And then so I know it sounds like a weird thing to say in the context of RL, but then if you're thinking about very hard things to solve in the real world, you're just gonna be bottlenecked by like, oh, I actually need to build like a better instrument to get data, right? So that sounds like a digression, but I'm just saying like very long term, like that's yeah, you're gonna hit those like kind of bottlenecks for verification. But in the short term, we can still like solve very interesting things like the Riemann hypothesis and stuff, hopefully. But also that will probably take quite a while as well. So.
Yeah. Yeah. I don't have anything particularly eloquent to say on the discovery point. I think that how people train language models right now will hold them back in a bit. So I think if these models that I guess what's going to happen is these RL is going to be in training and then you kind of punt it off to the rest of post training. So I think just models need to be
Yeah.
able to get really weird, but not weird in a way that they're just numerically lost. I've been reading a lot of reasoning traces these days, and the Quen and DeepSeek reasoning traces really just seem numerically lost for a while, and then they
Yeah.
poop pop out and get the answer right. It's like they'll be like doing the wait thing, but it'll be like half English, half Chinese, and then it'll just like end up getting the answer right. And I'm like, I don't know how that happened, but that does not feel like a mechanism to discovery.
I,
There's some kind of fundamental research on making this reasoning process a bit more real and to get there.
my other bear case against reasoning models is like, and this is mainly just like a devil's advocate point because I think I still fundamentally believe, but okay, so like since like World War II, right? There's a lot more like scientific, like human out, like workers like in the world, right? A lot more scientists. But like, would you say there's like more progress? Like, if anything, it feels like in a lot of sciences, progress slowed, right? Is there more progress in like fundamental physics like now, or was there in like 1945? And a lot of that is just because like the low hanging fruit is gone in like these kind of fields. But then that's also like a bear case that the bottleneck in a lot of places is not raw intelligence. It's actually just okay. Maybe it's like we need to like increase the speed of physical processes, or like be better at building like instruments for measuring, or maybe we need more funding from the government to build like a bigger particle collider, right? I mean, I'm exaggerating because I think AGI mostly means like regular activities like automating law and like finance and these kind of things, and I think that's a lot easier to do. But I'm just like, yeah, this kind of mindset that okay, we've solved like reasoning now, like super intelligence is going to come like a year, like next year, whatever. That's like, from what I can see,
Yeah,
like,
I'm bullish on AI being used and bearish on whatever super intelligence tails. Like we're just too compute constrained for some takeoff. I think
yeah,
AI is going to be very good for financialization and digitalization and seamlessly globalizing the internet and making all like information transfer and acquisition effectively free,
yeah,
which is really good. And I think like historically the US is actually very positioned to capture this by just making products that run on top of cheap AI models.
yeah,
But there's a lot to unfold that to get there.
yeah, yeah,
I wanted to ask you what AI you actually use. I don't know if I've ever asked you
yeah.
this, but it's normally revealing.
Okay, so what we're using right now, so the base models, what we're doing experiments mostly on Quen, Quen 3, but then also just some on Quen 2 still, just because we kind of know the quirks of that model a bit more.
A lot
And
of people
then
do that.
yeah, then we do some like distillation experiments, and we're just mostly still using DeepSeek R1, but we did use Kimi recently. Um, but like we didn't, in a weird way, for the benchmarks we were seeing, we didn't see massive gains, which is a bit unusual. But that's like the kind of stack we're doing. Then from a personal productivity like perspective, like yeah, Claude Code is like very very good. Um, my main worry with Claude Code is that like I think there's a paper on this, but I think people confuse like agents making you more productive versus oh agents prevent me from like exerting mental effort. So sometimes I'll have a day with Claude Code where like I use very little mental effort and it feels amazing, but I'm pretty sure I've done less work, and I think like that will change because obviously the models get better. But then I'm trying to teach myself to be a bit careful because sometimes I just need to.
It does seem like that equilibrium. I'm happy
Yeah,
with it. It's like I don't want to have to grind out some plotting code. I'm
yeah,
just gonna let it. I'm just gonna watch some fucking sports highlights and let it do it for me. That's fine.
yeah. But yeah, in general, very. I mean, there's lots of positive feedback on Claude Code, but that's like a very like impressive product for me.
What is the like niche of your use case, or is it a bunch of things? Like, do you
A
have
bunch of
something you
things.
think you could? Yeah, it's like
Yeah,
Lindor. It's wild.
I can't go
Do you do it
into
in complex
details.
code tasks? Like, are you using it in your
Good
like
question.
startups code base?
Um, it tends to be better with like brand new code bases, right? But it tends to be I use it mostly for tasks, which is like quite horizontally scalable. So I'll have some basic specification where it's like, I'll provide it some example code of like, okay, here's like what a good implementation looks like, but I need this done. Sorry, I'm being very vague because I don't want to talk about specifics, but like,
Yeah.
it tends to be better for that. And yeah, where it becomes really bad is if you just, I mean, it's obvious to say, but if the kind of file size becomes too long, then it begins to struggle and just like gets into these weird like kind of line search kind of mode. So yeah, there's a bit of work to do where you have to kind of structure the code base a bit for it to do be efficient. But in general, yeah, it's quite helpful.
It's such a success that pretty much everybody that tries it that is doing at least like small code projects is like, yeah, it works.
Yeah,
It's like that. This is like almost since like ChatGPT that there's been that good of a
yeah, agreed,
reaction.
right? Yeah, because I was trying to
And
think like,
that is it like the GPT 3.5 level? Like Claude 4 is like GPT 3.5, the original ChatGPT, and then a couple iterations is going to be incredible.
yeah, I guess the thing to think about is like obviously the people who really appreciate Claude Code are developers, right? But it doesn't have the mass appeal of a ChatGPT, which can, I don't know, generate poetry or whatever at the time, which is the killer use case at the time. It sounds crazy now. So I
But
guess
people will pay for Claude Code. People won't
yeah,
pay for ChatGPT.
exactly right. So maybe it's probably a lot better business model. But yeah, I think that's a good question. I wouldn't say it's the chat. I would say it's probably one of the most impactful products since ChatGPT, but I wouldn't call it a ChatGPT moment because it hasn't got
Yeah.
mainstream appeal yet. But and the question is like,
Yeah.
what does that agent look like? I'm still like shocked that Apple hasn't done anything yet because for me that would be the killer thing. We'll see if they get their shit together, but yeah, I would imagine it'd be like some kind of on-device agentic model would be my guess, but yeah, we'll see.
Yeah, that's fun. Did you also want to mention Alpha Evolve?
Oh yeah,
I've been so burnt by Google's like hypey projects, like their chip design and stuff, and I'm like, I know RL if you like I mean this is the AlphaGo story. If you have a really high performance simulator um that's well matched to a task and you can scale RL, especially like you scale to many actors in parallel and you can just get a lot of samples, it tends to create very high quality performance. So it's like RL is somewhat repeatable in that regards. It might not work in every domain. I think I talked to like I had one, maybe my last interview was with Eugene Vinitsky, which is one of my friends from Berkeley, and they
yeah.
were at Apple and they did this really parallel RL for self-driving simulator, which was really awesome. And I guess Alpha Evolve is somewhat away from that, but is it actually extracting the same vein of like simulators?
Is yeah, I think Alpha Evolve is very cool. In my mind, it's like very interesting because it feels like going full circle. Because in the '90s, like the hot things were like, well, the cool things which didn't quite work were like kind of genetic algorithms and then like neural networks, right? And it feels like we often see like a new lease of life for several algorithms once like other components get in place. So in the case of Alpha Evolve, you're exploiting the very strong kind of latent knowledge of a neural network, but then you also have like this almost neurosymbolic element. Don't read too much into that, Gary Marcus, but in the form of a database where you store past programs, and then just having that kind of prior in the program is just a very good way to exploit the internal creativity of a language model, as opposed to starting from scratch.
How does Alpha Evolve actually do this? I think a lot of people are just going to not actually know what it is doing. I don't
Yeah,
think I have a good knowledge of it, which is why I'm
so
like,
let's
oh.
say it's like a kernel optimization task. Like, so you're making a good kernel for like, I don't know, some common like ML architectures. So you start with like a reference implementation, and then in essence, you kind of using almost like it's a bit like in context learning that you're just like taking that and you're saying, okay, propose a change, and then you benchmark it and you get a score. And then you have a database where you have like you store that program and its score, and then when you sample like a new round, you kind of have an algorithm. You can look it up. It's like based on like island-based algorithms, where you kind of sample in proportion to like okay, it's score, but you also want to explore a bit, and that's your new prior. So you're kind of successively like iterating and evolving like a program.
And this is just handed off to the language model
Yeah,
to
and you just do it in
um
parallel. Yeah, yeah. So
what is the language model actually inferencing? Is it inferencing new programs?
yeah, so you
Because the
essentially imagine
programs
a
need to be
prompt.
executed.
Yeah, so imagine you're constructing your prompt, right? So you fetch like
Yeah.
a past implementation from your database, goes in, it probably have the score as well, saying, this implementation above got this result. Please propose a new thing. I mean, I was simplifying, but this is the essence of it. Propose a new, so then it writes a new program, get a new score, and back in the database. So basically, anything where you can pose like you can neatly pose it as a kind of like an optimization task. That tends to work very well. So I think the debate there, kind of alpha evolve versus RL. First of all, I think they can be complementary, but
it's like the language model is trained with RL. I bet.
Yeah, that too. I mean, the interesting thing, by the way, the bulk of the alpha evolve approach wasn't the strongest Gemini model. It was actually a weaker model, which is faster at inference. So that's like another interesting point, which is kind of anti-model scaling pilled. If that, there's like a nice balance to be found there. But in general, I actually see it as like a broader trend of like how to use compute if it's parallel or sequential, because that's like I would say the alpha evolve approach is like highly parallel, but they're not like going fully sequential yet, right? But you could actually kind of use both. Whereas the RL approach, you're kind of usually starting from scratch, right? But then you could also think of like ways you might want to, exploit good, priors in the context, right? I mean, kernel bench sort of does that anyway. It just doesn't evolve the reference implementation like alpha evolve does. So I think it's definitely something to watch on. I think alpha evolve is underhyped, but I think the way it'll end up,
it seems like a sign of things to come. When you can figure out parallel compute in the right way, I don't necessarily like. It might not be that the biggest model benefits the most in parallel compute.
Yeah,
I mean, there's a lot of ways you could think about this, which is just need more guesses. Like the guess is 100 times cheaper and half as good. It's like
I think it's. I know maybe this is a bullshitty philosophical point, but it's like, in the past like 5,000 years, right? So like humans have made like a lot of progress, but their brains fundamentally haven't changed, right? But what makes you smart is that you kind of follow a natural curriculum each time, right? So, the invention that you have now, always like you need some like previous invention beforehand, right? So in your RL context, like, would you rather start from scratch each time, or would you just use the best thing you have and then successfully iterate upon that and stand on something's shoulders, right? So I think that's definitely something to watch in the RL space, which is that instead of just trying to kind of like almost like alpha zero things from scratch, like how do you maintain existing implementations and iterate upon those, and that's also attention as well. And like if you're developing language models, because to your point about Claude Code, right, you can imagine having an agentic model that's very good for starting from scratch, but you could also have like a model that's very good at dealing with an existing code base. And the question is like, which is more valuable? And the answer is both. But then depending on how you actually use those models, you might end up preferring a model in a different way, right? So I think that I'm just trying to put it into a much bigger context and just like the alpha evolve algorithm, but it kind of plays into those different arguments.
Yeah, that's fun. I am not surprised. Like, there's going to be a lot more things like alpha evolve, which just kind of makes if a language model can do that in one domain, it mostly takes people that have expertise in their niche to do the muddling and fix things, and more will fall out. It is very remarkable that you could do like a zero order optimizer, like a genetic algorithm just on prompts to language models and actually get anything out. That is like such a major win for language models of being some fundamental unit of compute. It's really hard
absolutely.
to look beyond
and creativity,
to that.
right? Because like because the meme is like, oh, LLMs can't be creative. I'm like, at a fundamental level, like the softmax is like quite an expressive operation. You'll get creativity eventually. It's just a question of like, can you pick it out from the stuff you sample, right? So yeah, I think it's also proof of creativity. You found like these new like implementations in alpha evolve, and probably lots of other papers to come, which humans haven't made, right? So
I would also guess there's people doing stuff like that don't publish it. Where they've taken language models and just found like how to hill climb in their domain by setting up these weird loops. These strange loops. I think these are good things to end on. I think I'm kind of fading, so I think it's good. Thanks for coming back. I'm due a trip to London at some point. I don't think we've never met in person, but that'll happen at some point.
Awesome.
Good to see you.
Yeah, great to see you, Nathan. Yeah, I'll see you in a bit.